If you're sitting at home and you didn't do the DOM, I'm going to leave that on the board for you to copy it while I introduce you to the lesson. Today we're going to be dealing with piecewise functions. Piecewise functions, most people think are difficult, but they are really nothing more than multiple functions graphed on the same coordinate plane. That's it. And I'll show you what some of those look like. Here are some examples of piecewise functions. They are simply multiple functions that one of them you stop at a certain point and the other one you start at a certain point. So like, if I asked you to just graph 3x plus 5, don't worry, we're going to do it together. But most of you could probably remember back in geometry things slope, intercept, and you could graph that. Of course, even if you didn't, you could always make an XY chart. But say I only asked you to graph this for all values less than 0. So that's what we're going to start out doing. Actually, we're not. We're just going to work on plugging values into this, and we'll graph it in a second. Evaluate each piecewise function at the given values of the independent variable. Please notice, the whole thing about piecewise functions is noticing where they stop and where they start. We're going to use the top function for all x values less than 0, anything negative, and we're going to use the bottom function for any values greater than or equal to 0. So, f of negative 2, I would plug into which function? The top one, because we're using that one for x values less than 0. So that'd be negative 2 times 3. What would this be? What does this equal? Negative 1. F of 0, I'll plug into which function, Josh? Very good, because equal to 0. And what's that going to equal when I plug it in? 7 it is. And Savannah, which function am I going to plug the third one into? No problem. Which of those two functions am I going to plug part C into? Very good. Why? Right. It's greater than 0. So we plug it in. 4 times 3 plus 7 is 19. Very good. Now, I didn't ask you to graph this, but if I had, this is what it would look like. I'm just going to free sketch this. Let's see. 3x plus 5. Let's say this is 5. 3x is going to look something like this, well, without the curve. And then you would stop because it's less than 0, and it would be open because there's no equal sign. And then we would start this one at 0. That has a y-intercept of 7, and it would be actually a little steeper. So this is what that function would have looked like. It's two separate things graphed on the same coordinate plane. Oops, forgot my arrow. So that's just a quick sketch of what that would have looked like. 39. Let's see. Part A. Olivia, what's part A going to be? Yes. Which function we plug it into? Very good. So it is the top one. And what's it going to be when you plug it in? Very good. Part B. Troyan. The second one, because it's less than negative 3. And let's see, what would that be when you plug it in? 3. Negative 6 plus 3 is negative 3. Negative 3 will make that positive 3. And part C, Alyssa. Very good. Why? That's right. It's equal to negative 3. And what would that be? 0. Very, very good. 41 would look a little different than all the others because 41 is going to basically be something like this. I'm going to sketch it down here. It's just one big equation. I don't know exactly what it looks like, but it's one big equation, except at one exact point, we're going to graph something different. And what point is that? What point are we graphing something different at? What x value? You can usually tell if you look at the right-hand side of a piecewise. 41. Which x value do you think is going to be different on this function? What x value do you think is going to be different for this function? 3. Yeah. You're going to graph the whole thing, but But at one exact point, and why do you think they chose that exact point? Look at the original. What happens if you plug that point into the original? It's undefined. Exactly. So what they did was they put in a piecewise to kind of cover their bases there. So originally you would have a gap here, but instead, I believe the way this is going to work out if you were to actually do an XY chart is this is going to nicely fill that little gap right there, and therefore make it a whole function. So you're going to use the top equation for every x value except for this one. 5, top one. B, top one. Any number at all, unless I ask you for exactly 3, in which case there's not even an equation here. What's my y value just going to be? 6, yeah. It's just giving you basically a coordinate, 3, 6. So if you see one of those, that's what you do. You plug everything into the does not equal equation, and the only thing you need the other one for is that exact spot. Questions about that? No problem. Are there questions about anything you see on the board right now? Now the graphs were just sketches. You don't have to do those yet. I was just showing you what these things represent. Okay. Can I move? All right, great. Okay, in exercises 43 through 54, the domain of each piecewise is negative infinity to positive infinity. Graph each function. Use your graph to determine the function's range. Okay. So when we graph these, I'm going to take these all to their own little separate places. When we graph these, you do not have to do tons and tons of points. What I would do if I were you, well, what you need to do, let me just word it like that, is find the breakpoint and then graph each piece of the function, maybe 3 or 4 points on either side of it. So where does this thing split? At what x value does this function split? 0. Very good. 0. So here we go. I'm going to start with the first function. I'm going to make an xy chart, or an f of x chart. Doesn't matter. Now I'm going to start at my breakpoint. Now even though it doesn't equal, I still have to know where it's going to stop. So I'm still going to start at that breakpoint. And then what values should I plug in along with 0? Who can give me some, what are some other values in that fit this description right here? -1, -2, -3, and that should be plenty. So we're going to plug those into the top equation. And when we plug those in, -0 is just 0. -1 is just 1. -2, -3, bam. Now we can go ahead and graph it at this point, or I like to go ahead and knock my XY charts out of the way. So I'm going to go ahead and make one for my other function. What value should I plug into the bottom one? Start with your point and then positive. 1, 2, and 3, because these are positive numbers. You plug them in and you get 0, 1, 2, and 3. Now we're ready to graph. The first, because I can't write. Thank you. So here we go. The top one. Start with the point. 0, 0. Excuse me. Pardon. It is open because there is no equals. -1. -1, 1, 2, 2, 3, 3. Connect the dots, and you can kind of just put your arrow when you can tell where it's going to go. Now for my second piece of the equation, where do I start? 0, 0 is going to be whole or open? Whole. I hear people saying the answers, but I can't hear you loud enough to so please speak up. 0, 0, 1, 1, thank you. 2, 2, 3, 3, connect the dots. And there you go. So what was open for one of the functions ended up getting filled in with the other function. So there you go. It ends up looking just like an absolute value function. And there's a piecewise. Two different equations graphed on the same coordinate plane. They will not always connect. That was just a fluke. Raise your hand if you have a question about where I got anything that's on the board. Any of the values, any of the graph. Okay. Look up here. What's another one you might... Oh, I'm sorry. Determine the range. I didn't see part B. What's the range of our function? The whole thing. 0 to infinity. Very good. 0 to infinity is the range. What's another one somebody would like to see? $47, $45, $49. Which of those looks troubling? None of them? 45. Okay. 45. Did you say one of them too? Oh, I'm sorry, I didn't hear you. Louder, sir. I'll do that in just a second. 45. Okay, where's our breakpoint? Where does it split? 0. So, what am I going to plug in? Sabrina, what am I going to plug in for the top equation? We're on this one right now. Less than 0. There you go. And that's good. Very good. So, we'll plug those in. 0, -2, -4, -6 is what I'm getting. Feel free to check my math. And what am I going to plug into the second equation? You got it. Now, these are all splitting at 0, so they're nice and neat. Negatives, positives. If it had split at 4, you would just take 3 values on either side of that. 3, 2, 1, 5, 6, 7, etc. Anywho, so we're going to plug these in. What are my y values going to be on the bottom equation? 2, 2, 2, 2, 2. Okay, let's see. Y values going down to -6, up to 2. Make it a little bottom heavy. -1, -2, -3, +1, +2, +3. Here we go. 0, 0 for the first one. Open or close? Close. -1. Oh, I'm going to need more down here. 4, 5, 6. -1, -2, -2, -4. Now, because of my horrible scale of my graph, the slope's probably not going to look just right, but oh well. All right, connect the dots. Well, I should have done that in blue. Oops. That goes with the blue one. Should have done that in blue. I'll just stay in red for the second part. Where am I going to start with my second one? At what coordinate? Open or closed? Open. And then plot the other points, connect the dots, and that's what it'll look like. I get it. Questions about where any part of that came from? All right. Right. Thank you. Range. How low does this thing go? Now, what makes this range different than the last one? Yeah, they're separate. There's a gap. So first thing we have to do is the first piece. And Troy, why don't you just go and take this? How high does the first piece go? 0. Closed, because it hits it. And what's the second part of the range? Just 2. And it does touch it, so I'm just going to put that in brackets. -infinity to 0, and then 2. 2-part range. Questions? Okay. Good question. The equal sign.
Okay.
If it equals, then your end point will be closed, and if it doesn't, your end point will be open. Good question. Still want to see 47? Sure. What's my breakpoints? -2. Now, your breakpoint won't always be the same. This one could have ended at -2. This one could have started at +5, and there'd just be a huge gap, and that's okay. But a lot of times they break at a common point. So, what am I going to plug into the first one? Jared? What am I going to plug into the first equation? You always start with the endpoint. Very good. And my second one? We'll just go ahead and get these XY charts drawn. What's going to go in this one? Perfect. Perfect. Let's see, who looks for? Jordan, what are my Y values for this top one? Very good. What are they going to be for my second one? Just go ahead and finish it out. You got it. All right, here we go. Ready to graph. All right. Ooh, that was no point in centering this. I'm only doing one positive number. All right, -1, 2, 3, 4, 5, +1. That covers my x's. Need to go down to -5. 1, 2, 3, 4, 5, +1. Okay, here we go. I'll try to do this color coordinated this time. -2, +1. Open or closed? Open. -3, 0. -4, -1. -5, -2. And -2, -5. Open or closed? Closed. -1, -4. -0, -3. Boom. And there is that piecewise. Questions? And you guys look like this is the most exciting lesson of all time. I'll just make up more examples then. What is wrong with me, Jared? Alright, what is my range? Yeah, very good. This one's going to go down to -infinity. There are no gaps, not really, because it's going to overlap. And this one goes up to infinity. I would get serious points taken off of this homework if I were doing it. Question, no, you already didn't have questions. Why would that have changed? Okay. Here are two others. 51 is just like the last ones we just did. The only difference is the functions are a tad more complicated, but you're just plugging numbers in, so your drawings will have a little more curve to them. 43 is a little different, or excuse me, 53. Why is 53 different? Yeah, it's got 3 parts. So let's just sketch this thing real quick. I'm going to make XY charts too, but -4, 0. So I have 3 XY charts. 1, 2, let's go green this time, and 3. All right. My first one, what do I need to plug into it for my x values? Sooner somebody speaks up, sooner we can be done. Okay, that's motivation. Negative, well, what do we always start with? There you go. But then we go to -5. -6, -7. What about the red one, Joey? You can just champion this one. And yeah, whenever you have an enclosed one like this, you definitely want to do both endpoints. And when it's as small as that, you might as well do every point. Now, if it was like 50 points, but it had both endpoints, it won't be. But, you know, just pick a few in between. And the third one? You got it. All right, plugging these into my top equation, what are my y values going to be, Taryn? Yep. Yeah, straight down, right? All right, what are my middle ones going to be, Holly? Very good. Again, we're just plugging these values into the equations they go with. And what are my green ones going to be, Kayla? It's okay. I appreciate your honesty. If I plug 0 into this function, what's it going to equal? And then 1. You got it. We're ready to graph. Negative 4, 0. Open or closed? Open. Negative 5, 0. Oops, open, open, close, close, close. Go ahead and graph that part. It's right on top of my axis. Red 1, 0, 0. Open or closed? 0, 0. Open or closed? Open. Because at 0, it does not equal. So open. And then negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 4, 4. Open or closed? Oh, what? Closed. Because at negative 4, it equals. Connect the dots. Straight though, without a curve, preferably. And 0, 0. Open or closed? Closed. So we're just going to fill in that gap. And then 1, 1, 2, 4, 3, 9. Put a little curve in there. And there's your piecewise. I'm not going to forget it this time. What is our range, Sarah? What goes here? You got it. 0 to infinity is our range. Questions? Okay. Okay. Good. Good, good, good. We have 50 minutes. I'll tell you what. I'm going to let you go ahead and get started on the first part of the homework. And then in about 30 minutes, we're going to reconvene. I'm going to show you one last thing and tax 2 or 3 extra problems on there. But I want you to focus on these piecewise for now. So, hold on. What number did that go to? 50. I'm making sure the rest of the numbers line up. 38 to 50. I guess that would have made it 4. There you go. It doesn't have entirely to do with what you've been working on. So that's why I made them separate. Here's what they are. We're going to be doing some of this kind of algebra all year. So I'm just going to go ahead and sprinkle these in now so that you can be working on it and get your mind going. Dang it. Here's what you need to do for these problems. It's actually exactly what it's. This is off. It exactly shows you how to plug it in up top. Now, again, bear in mind, if you're trying to look for a connection between this and what we were working on with Piecewise, there is none. This is just something that it doesn't really go with anything. So if you had to tack it with one lesson, I chose this one because this whole lesson was just one thing. So here's what you're going to do. You're going to plug all these equations into this equation. Plug all these functions into that equation. Example. I'll just do x squared. So, first off, I need to evaluate f of x at x plus h. You know, just like that first day we plugged different things like x plus 2, 7 into functions, I'm going to do that same thing with f of x. So, that's going to be f of x plus h of x squared becomes x plus h squared. Okay? What I'm going to do first is just write these out, what they would be with our equation in there, and then I'll plug them all back into this big hunky-dory thing at the end. Now, what is x plus h squared? How would I solve that? FOIL it, yeah. You have to FOIL it. X plus h times x plus h. So that becomes x squared plus, oops, wrong one, I already did that one, plus xh plus xh plus h squared, which becomes x squared plus 2xh plus h squared. So that is just this piece right here. Is this. This is what you're going to have to do every time. You need to find the first part. Now the second part, f of x, well, that's exactly what the equation already is. So that's just x squared. Now I just plug those into this formula. So I'm just going to give myself some room over here by covering these up. You plug those straight into the formula. First off, f of x plus h. X squared plus 2xh plus h squared. That's f of x plus h. Minus f of x. All over h. Now, just in the numerator, what simplifies? What cancels or anything? The x squared. X squared minus x squared. And here's the thing, if you do it right, that should always happen. Some kind of piece should cancel with that second part. That leaves you with 2xh plus h squared over h. What factors out of the top? What's in both parts of the top? An h. Leaving you with h times 2x plus h all over h. Now what cancels? H's. And the finished product, your answer to 59, when you plug this equation function into this equation, you get 2x plus h. I know you're thinking, why on earth would I need to do that? Well, we're getting to that. But you need to practice the basics of it before we can get to why. So that's what you're going to be doing. And I'll work out another one real quick too. Is this what? Well, I'm only going to give you like 3 or 4. But yes. Let's look at one more. I'm going to take this. You know what? I'll just go to a different slide. Let's look at one more. Let's see. 65. No, 67. Let's see even harder. Might as well knock out the hard ones first. Alrighty. So, just like the last one, first thing you need to do is find f of x plus h. That's the hardest part of the whole process, if you ask me. So that's going to be negative 2 times x plus h squared plus 5 times x plus h plus 7. Negative 2. Now, you should, if you just went back one slide, x plus h squared will always be that same thing we already FOILed once. Now, you can FOIL it by hand a little slower if you want to, but it's always, anytime you square the same thing, it's going to get you the same thing every time. So, plus 5x plus 5h plus 7. What's the only thing I have left to do to this piece? I can't hear you. Yes, combine like terms, but what's the first thing I need to do to this part? Distribute. Very good. Negative 2x squared minus 4xh. I'm just multiplying through by that negative 2. Plus 5x plus 5h plus 7. That piece is done. We don't have any more like terms. That's the hard part. And then f of x is just going to be the original function. So here I go. F of x plus h. I'll write it out here again in case you didn't see it in the last slide. Here's what we're plugging it into. So f of x plus h. Negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h plus 7 minus f of x all over h. Now again, if you did this correctly, everything on the right hand side should cancel. Negative 2x squared, positive 2x squared. 5x minus 5x. 7 minus 7. If you did it correctly, everything on the right-hand side should cancel, leaving you with negative 4xh minus 2h squared. I think that's it, right? Oh, plus 5h. Thank you. All over h. And if you do it correctly, that same step that we did in the last one should always occur. You should always be able to factor an h out of the top, leaving us with h times 4x minus 2h plus 5. I just took one of those h's out of all three, over h. You should always be able to cancel this, and you will always be left with some kind of equation, something like that. And that is your finished product for that problem. It is a tad time consuming, but I think we can agree by far the hardest part is the f of x plus h step. If you can get that, the rest of it's not bad. There's two examples. I'm only going to do maybe 3 of these on your assignment. Let me, I'll come back and put it on this in just a second. Let me just see which numbers I want to add. How about 56, 60, and 68? I'm just going to write it right here. The numbers to add to your assignment are 56, 60, and 68. We'll just do 3 of them. Maybe we'll start tomorrow with a DOM of 1, 2. 56, 60, and 68 need to be added to your assignment.